All right, so for this first one, we're going to add the 4 to the other side. And again, if you write sort of small, you're going to be able to fit this on here. Obviously on the test, I'm going to give you a lot more room. If you write kind of big, you might want scratch paper. Then we're just going to add over the 4, and then we're going to square root. Now, when you put a square root, what do you have to put? Plus and minus. So secant of x equals plus and minus 2. Square root of 4 gives you 2. And then I'm going to reciprocate that. Which function is your reciprocal for secant? Good. So we're going to have cosine equals plus and minus a half. If you reciprocate 2, it's going to be a half. I kind of like when it's plus and minus because you don't have to worry about what quadrant you're in. What quadrants are you in? Yeah, all of them. And it looks like a bow tie, which is just cute. And please make sure you draw the picture. That's like the work showing you like where your answer came from. Cosine is x. So the 1/2 would go here. That's going to be super tiny, so I'm not going to write that. But if that's 1/2, what is this side going to be? Square root of 3/2. And then here's the whole point. What's your angle across from that? Pi/3. So we are getting 4 answers. And this is where you just need to know your unit circle. This is why I made you fill out so many of them. It's going to be pi/3, and then what's the one in the second quadrant? 2 pi/3, and then in the third quadrant, 4 pi/3, and then 5 pi/3. All right, number 18. You would subtract the 1, so 2 cosine x/2 equals -1, and then divide by 2. Oops. I said divide by 2, and then I didn't read it. Now we do have to worry about what quadrants we're in for this one, because it's not plus and minus, it's just negative. Cosine is the x value, and it's negative. So what quadrants is x negative in? 2 and 3. Good, you went like to the left. So it's sort of like a kite or like half a kite. So the -1/2 would go right here. I know that's really small. The other side then would be square root of 3/2. And so your angle is pi/3. Now this is one of the ones like what we did last time. It's not just cosine of x. Like when we looked over here, it was just cosine of x. So we didn't have to worry about it. This one's cosine x/2. So what does that mean? Yeah, you're only going halfway around. So we're not going to get the other answer. We're only going to get one answer. And instead of x equals, it's x/2 equals, and this would be 2 pi/3. So just look out for those ones that have like an x/2 or like a 2x or a 3x, because it tells you how many times you have to go around. And then to get rid of this 2, we have to multiply by 2 to cancel that out. And so we get x equals 4 pi/3. And that's the only answer you get, because again, you only go halfway around, so you don't get to the other answer. All right, for this one, we're going to subtract the 1. And then divide by square root of 3. And then that's not on the unit circle. So you have to like back up a step and write it as something that is on the unit circle. So it will be negative what over what? Yeah, good. 1/2 over square root of 3/2. So it's cotangent and it's negative. So when you're figuring out what quadrants to be in, it can't be quadrant 1 because everything's positive there. So if it's negative, it can't be quadrant 1. And the way I remember these is tangent and cotangent just go across from each other. So it's going to have to be 2 and 4. And you can memorize that ASTC thing, but I just remember the tangent and cotangent go across from each other. And if it's negative, it can't be quadrant 1. So that's how I kind of do that in my brain. So cotangent is x over y. So x is going to be the 1/2. Square root of 3/2 is going to be the y. And so our angle, again, is pi/3. Now here's the kind of not fun thing about this problem. How many times are we going around? 3 times. So how many answers are we gonna get? 6. Okay, it's tedious, but not difficult. You just have to keep going around and around. So we're gonna get 3x equals, all right, here we go. 2 pi over 3. And then 5 pi over 3. Now we're gonna add on another rotation. The whole way around is 2 whole pi. So in thirds, what are we adding? Good. Basically, you're just adding 6 to each of those numerators. So it would be 8 pi over 3 and 11 pi over 3. And then you have to go around one more time. So you're going to add 6/3 to both of these. We're going to go around one more time. So 8 plus 6, that would be 14 pi over 3. And 11 plus 6 would be 17. So 17 pi over 3. And then the last step is to get x by itself, you have to divide by 3. So when you divide by 3 and then you divide by 3 again, and now you've divided by 9. Good. So you're going to write all of these over 9. None of them are going to reduce. So you can just like mindlessly copy them all over 9. So again, it's like tedious, but not difficult. You just have to write it out. I didn't hear you complaining, so I think we're doing okay. All right, what would you do first in this one? Divide by 2, so we get sine squared equals 1/2. And then again, to get rid of the squared, we're going to square root, which means we need plus and minus. All right, when you square root 1/2, square root of 1 would just be 1. And then square root of 2 is square root of 2. Without a calculator, that's just square root of 2. How is that going to rationalize? Oh my gosh, it's square root of 2 over 2, you guys. It's on the unit circle. And because it's plus and minus, we are in all 4 quadrants. And what is the angle for our square root of 2 over 2? I over 4, perfect. And it's just sine of x. There's not like a 2x or a 1/2 x or anything like that. So it's just regular old go around the circle one time. And so we're going to get 4 answers, pi over 4. And then what else? 3 pi over 4, 5 pi over 4, 7 pi over 4. This one should remind you of a trinomial. It should look like 4x squared minus 4x plus 1. Are you following me there? We're going to break it apart just like we would a trinomial. It's just instead of splitting x and x, it's going to be cosine and cosine. And actually, we also have to deal with that 4 out front. You can split it 1 and 4 or 2 and 2. What do you want to try? And if we guess wrong, we will just erase it. It's not a big deal. Do you want to do 1 and 4 or 2 and 2? 1 and 4. All right, let's see. Cosine x, 4 cosine x. And then 1 is just going to split 1 and 1. And we have to get the outsides and insides to give us -4. So outsides give us 1 cosine. Insides give us 4 cosine. So 1 and 4 is not going to make 4. That's actually not going to work. So what are we going to do instead? It's not a big deal. Let's do 2 and 2. If you try something and it doesn't work, just try something else. So now we've got 2 and 2, that'll make 4, but it's a -4, so what symbols do we need? Yeah, good, they'll both be negative. If you do 1 plus and 1 minus, they'll cancel out. That's not what we want. We want them both negative. This is actually good. You want to be happy about that. Why? They're the same thing. You don't have to do 2 separate problems. You just get to do 1 problem instead of 2, which is less work, right? you would add 1 and then divide by 2. So we're going to get cosine equals 1/2. That's positive. So what quadrants is cosine positive in? It's the x value. So 1 and 4. The 1/2 would be along the x-axis. So the other side's square root of 3/2. And so our angle is pi/3. It's just cosine of x. So there's nothing fancy there. It's just go around the circle once. We're just going to get 2 answers. It'll be pi/3 and 5 pi/3. When it's just x, you just go around the circle 1 time. It's just like regular old answer the question. This one we're also going to factor, but instead of like a trinomial that gets split, this one is just GCF. What have they both got that we can factor out? Sine of x. So we put sine of x, parentheses. What's left once you divide out a sine of x from both of them? Good, +1. Anything divided by itself gives you 1. And then this one, we are going to have to do 2 separate problems. We're going to set both of those equal to 0. So let's do the first one. That would be sine equals 0. And that's not going to give us a triangle. That's going to be the circle. Sine is y. So where is y 0? Up, down, left, right. Left and right. Good. And again, it's just sine of x. You just go around the circle once. So we're just going to state those 2 answers. So what's this first one? If you didn't rotate anywhere, yeah, no pi. And then this would be 1 pi. And then we're just going to set the other factor equal to 0. So you would subtract over the 1. And then that one's tricky because the -1 makes you think of the circle. But for tangent and cotangent, that's not the case. It's going to be a triangle. We're going to be in quadrants 2 and 4. Again, those ones go across from each other. And how do you end up with 1? I mean, I realize it's -1, but how do you end up with 1? The sides have to be what? Yeah, anything over itself will be 1. So it's going to be square root of 2/2. It's just one of them's negative. That's how you get the negative in there. And so your angle is pi/4. Again, you have way more room on the test. I spread everything out on the test. On this, I kind of like was trying to save paper. So you're just going around the circle once. It's just get those 2 answers. So what's this first one? 3 pi/4, good. And then 7 pi/4, awesome. Yeah. If it's positive, I know it's quadrant 1. Because everything's positive in quadrant 1. So then it'd be 1 and 3. So if it's negative, I know it can't be quadrant 1, so it has to be 2 and 4. That's how I do it. You're welcome to memorize it however you want. That's how I put it in my brain. Positive is quadrant 1, so it'd be 1 and 3. Negative is it can't be quadrant 1, so it has to be 2 and 4. Yeah, of course. All right, what would you do first for this one? Yeah, plus square root of 3. And then we can do both these steps together, I think. Then you would divide by 2, right? So it would be square root of 3/2. Oh my gosh, it came out to something on the unicicle. It's sine, and that's positive. So where is sine positive? 1 and 2, it looks like kitty cat ears. And across from the square root of 3 is pi. You know, I made a lot of these pi/3. There aren't a whole lot of choices, though, to be fair. And it's just sine of x. So you just go around the circle once and get these 2 answers. It'll be pi/3 and 2 pi/3. That was an easy one. I like that one. And then for this one, you would add 1 and then divide by square root of 3. And so if you back that up one more step, it would be 1/2 over square root of 3/2. So since that's positive, I know I need to be in quadrant 1. And so what's the other quadrant that it's going to be? Yep, 3. Perfect. And again, cotangent is x over y. So the 1/2 is the x, square root of 3 over 2 is the y. Man, I need all these square root of 3 over 2. Just to be clear, if it was the other way around, what angle goes across from the 1/2? Okay, you guys know that. I only have 3 angles to choose from. All that there is. And it's just cotangent of x. We're just going to go around the circle once and get our 2 answers. So it'll be pi over 3 and then 4 pi over 3. All right, so these last 4 say solve for all solutions. The trig functions are cyclic, so it's going to keep going forever and ever and ever and ever. So this is where we add the 2 pi n or the pi n or the pi over 2n. Are remembering this sort of like where you just keep the cycle going, okay? But it starts out the exact same way. For this one, to get rid of the squared, you would square root. So you're going to need to put plus and minus, and your square root of 1 is just 1. So plus and minus 1. So we are in all 4 quadrants. And then what do the sides of the triangle need to be so that you end up with 1? Yeah, good. Anything over itself is 1. So they have to be the same thing. Square root of 2 over 2. And so your angle is pi over 4. So this is that kind of special situation where these are exactly evenly spaced from each other. So it is going to be pi over 4 plus pi over 2n. You can just go a quarter of the way around the circle and just hit all of the answers. It only works for pi over 4. It's the only one that's evenly spaced from each other. If it's pi over 3 or pi over 6, that's not going to work. All right, for this one, we would add 1. And that's not going to give us a triangle. That'll give us the circle. Sine is the y value. So where is the y value 1? Up, down, left, right. Up, good. 0, 1. And so what is that answer? We'll start with that. Good. Pi over 2. And then you have to decide, what are we going to add on to hit that answer again? Well, you have to go the whole way around to get there again. So we would add what? 2 pi n. You have to go the whole way around to get back to that answer. So again, it's either the whole way around, halfway around, or a quarter of the way around. And this is the only one that works for a quarter of the way around. All right, for this one, you would add 1 and then divide by 3. So we'll have tangent squared equals 1/3. We add 1, divide by 3. And then square root. So again, when you do a square root, you have to put plus and minus. Square root of 1 is just 1. Square root of 3, square root of 3. Without a calculator, I don't know exactly what that is. And then we're going to back up one more step. It'll still be plus minus 1/2 over square root of 3 over 2. And again, if you feel like you're worried about that, don't. It's either 1/2 over square root of 3 over 2 or the other way around. If you aren't sure, pick one way and go with it. Okay, you got a 50-50 shot. Now we are in all the quadrants since it's plus and minus. So draw your little bow tie. And tangent is y over x. So 1/2 is the y. Square root of 3 over 2 would be the x. That's kind of small, so I'm not going to really fit that in there. But the point is, what's the angle across from a half? Pi over 6. Now you can't knock these all out at once like we did the one right above it. Pi over 4 is the only one where they're all evenly spaced. So we're going to have to write 2 separate statements for this. So the first one, we'll start with pi over 6. And if you go halfway around, you're going to hit this answer. So what do I add to go halfway around the circle? Yeah, pi n. 2 pi is the whole way around. So if I just add pi n, that's halfway around. So that statement takes care of these answers, quadrant 1 and quadrant 3. If you keep going halfway around, you're going to keep hitting those answers. So the second statement is going to take care of these two. So what is our answer for the second quadrant? How far did we rotate to get to there? 5 pi over 6, good. And then add pi n. Halfway around will land you here. And so that statement takes care of these two. So again, you have to write it two separate because they're not all evenly spaced from each other. All right, and then last one, you would subtract the square root of 3, so it's going to be negative square root of 3, and then divide by 2. So cosine equals negative square root of 3 over 2. Cosine is the x value, so where is the x value negative? What quadrants? Well, 3 is one of them, 2 and 3, good, because you went like to the left is kind of how I think of that. If cosine is x and that's negative, we went to the left. So this would be your negative square root of 3 over 2. That means this side is 1/2. And so our angle is pi over 6. Now, again, you're going to have to write two separate statements, one for each of those. So this first one's 5 pi over 6. And how far do you have to go to hit that answer again? Yeah, you have to go the whole way around, right? So plus 2 pi n. And then we're going to do the exact same thing for this one. That one would be what? 7 pi over 6. And again, you have to go the whole way around to land there again. So plus 2 pi n. So 2 pi is the whole way around, pi is halfway around. And then this is the only situation where the pi over 2n comes into play.